Occupational Noise Exposure in Construction, a discussion on hazard control measures and hearing conservation programs. Your presenter for this program is Jason Griffin. Jason is the Corporate Safety Director for Fessler Bowman Incorporated and is a former MIOSHA Senior Construction Safety Consultant. In this program, we will be discussing the following points: the definition of noise and OSHA's permissible exposure limit for noise in construction, the elements of an effective hearing conservation program, the control methods used according to the NIOSH hierarchy of controls, various types of personal protective equipment used for hearing protection, and some resources available to employers and employees interested in getting more information on this topic. What is noise? Sounds are vibrations or fluctuations in the pressure of air or other media which affect the human body. These fluctuations, when detected by the human ear, are translated to our brains as sound. We use the term noise to indicate unwanted sound. Repeated exposure to noise fluctuations at higher pressure levels or volumes can cause harm to workers over time. The time it takes to cause injury varies according to the pressure levels. How does hearing work? The human ear can hear an audible range of sound from about 20 Hz to about 16,000 Hz. When an individual develops hearing loss, they typically lose hearing in the 4,000 to 6,000 Hz range first, followed by other frequencies. These are the main frequencies between which normal speech occurs, and hearing loss at these frequencies makes it difficult to understand speech. In this video, you will see how sound is processed by our ears.
Have you ever wondered how sounds make their way from the source all the way to your brain? Take a trumpet, for instance. When it's played, it makes sound waves in the air. The outer ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates 3 tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower-pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest-pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize and understand.
How much noise can I be exposed to in a day? OSHA's occupational noise exposure rules require that an employer implement a continuous and effective hearing conservation program if sound levels exceed the values shown here. The National Institute of Occupational Safety and Health, or NIOSH, has issued a recommended exposure limit of 85 decibels for an 8-hour workday. Studies have shown that workers exposed to noise levels greater than 85 decibels will experience hearing loss over time. In OSHA's General Industry Standard, 29 CFR 1910.95 standard for occupational noise exposure in general industry, OSHA prescribes an action limit of 85 decibels. If the action level will be exceeded, then employers must develop a hearing conservation program. OSHA also describes the minimum elements that the program should contain. This action limit helps to ensure that employees will not be overexposed to noise. This is important because when looking at table D2, shown here, we can see that an increase of just 5 decibels from 90 to 95 cuts our maximum exposure time in half. Repeated exposure to sounds at these levels will ultimately damage our hearing without appropriate safeguards in place. The Hearing Conservation Program will describe the methods utilizing sampling, engineering controls, and as a last resort, PPE to minimize the effect that noise has on us. Remember, the action limit is 85 decibels and that the OSHA permissible exposure limit, which is the maximum amount of noise that we can be exposed to, is 90 decibels over an 8-hour time-weighted average. Common construction noise sources. This table shows some common noise exposures in construction. It is important to know that the environment around us can impact the noise levels that we are exposed to. For example, if I am working outdoors where the sound has the ability to travel away from the source unrestricted, then I would expect the noise level shown here. However, if I change the environment and surround myself with hard surfaces such as walls, then the sound will hit those obstacles and bounce back at me, increasing the overall noise to which I am exposed. It is for this reason that it is important to monitor noise levels for employees working in various conditions to make sure that the control methods that we have selected to control the noise are effective at keeping the overall exposure levels at or below the PELs shown on the previous slide. Hearing conservation programs, a review of the program elements. In this section, we will be reviewing the required elements of the hearing conservation program. OSHA's Occupational Noise Standard for Construction does not include the information about what should be included in these programs. To address this at the national level, OSHA issued a letter of interpretation on August 4th of 1992 that a hearing conservation program in the construction industry would consist of the elements shown on the next slide. The references for the elements described in this section were taken from OSHA's 29 CFR 1910.195 Occupational Noise Standard for General Industry. Program elements. 1. Monitoring of employees' noise exposures. 2. Institution of engineering, work practice, and administrative controls for excessive noise. 3. Overexposed employees must be individually fitted with appropriate noise-reducing hearing protection devices, or HPDs. 4. Training on noise hazards and the protective measures. 5. Baseline and audiometric testing. 6. Procedures to prevent the recurrence of hearing loss injuries. And 7. Record-keeping provisions. MIOSHA Guidance Document. In Michigan, MIOSHA created a guidance document to assist employers with the development and implementation of the Hearing Conservation Program. While not a template specifically, it discusses in depth what each component of the program should look like. This document is available for download from the course materials or by scanning the QR code shown here. Exposure monitoring. In most cases, when monitoring for noise, you want to take a reading near to the level of the exposed employee's head or at the surface of the sound to determine what the noise level is measured in decibels. In a free field, as shown here, as the sound travels away from the source, it loses pressure, resulting in a measurable drop in the decibels. The pressure typically drops by half whenever the distance from the source is doubled, as seen in Figure 4. There are also times that it is necessary to take a measurement of the ambient noise of an enclosed space. The tool you want to use to take the readings is called a dosimeter or sound meter. In spaces defined by walls, however, sound fields are more complex. When sound-reflecting objects such as walls or machinery are introduced into the sound field, the wave picture changes completely. Sound reverberates, reflecting back into the space rather than continuing to spread away from the source. Most industrial operations and many construction tasks occur under these conditions. Figure 5 illustrates sound radiating from a sound source and shows how reflected sound, represented by the dashed lines, complicates the situation. In cases like this, the reverberant sound can be amplified and result in higher readings than would occur in the free field situation seen previously. Hazard prevention and control, a look at the NIOSH hierarchy of controls. Types of controls. In this diagram, eliminating the noise is the best way to handle the exposure, but in many construction operations we are unable to eliminate the noise exposure. So we have to work our way down the hierarchy of controls to explore other options. OSHA requires that we implement feasible engineering and work practice controls prior to putting employees in personal protective equipment. PPE is considered to be the least effective method of dealing with the hazard because it relies the heaviest on employees using the equipment consistently and correctly. Generally speaking, as we move from the top of the hierarchy to the bottom, the less effective the measures will be at consistently controlling the hazards. In most cases, employers must use a combination of the controls to mitigate the hazard caused by exposure to noise. Buy Quiet for construction. The NIOSH Buy Quiet initiative encourages employers to select, purchase, or rent the lowest noise-emitting power tools and machinery in order to reduce occupational noise exposure. This initiative provides information on the equipment noise levels and encourages manufacturers to design quieter equipment. The video shown here will discuss how the Buy Quiet program for construction is designed to work and represents the first step of the noise control process, which is substitution.
Hi, I'm Guy Quieter. We live in a noisy world. With more equipment available every day, noise-induced hearing loss is a real concern that impacts our safety, our daily lives, and our general health, including those working in construction. It's time we focus on controlling noise at its source. Did you know that hearing loss is the most common work-related injury in the United States? Approximately 22 million U.S. workers are exposed to hazardous noise levels each year, and up to 50% of construction workers may have some job-related hearing loss. It's quite common to find a 25-year-old construction worker with the hearing of an average 50-year-old, and once you experience permanent hearing loss, you can't get it back. The problem doesn't only affect construction workers. Construction noise is the biggest complaint cities receive from residents, and some city governments have already taken action by restricting construction hours and by providing an approved equipment list, forcing companies to use quieter equipment. The good news is there are things you can do to protect your employees, coworkers, and your communities from the harmful effects of noise. Buy Quiet is here to help you. Buy Quiet is focused on reducing noise at its source by providing information on equipment noise levels so you can buy quieter products that make construction sites safer, encouraging manufacturers to design quieter equipment by creating demand for quieter products, helping you comply with OSHA requirements, reducing noise impact on the community, and, most importantly, helping you reduce the risk of hearing loss. Worried about the cost benefit of going quieter? Doing nothing to reduce noise-related hearing loss carries a high price. Do you know businesses in the United States spend $242 million annually on workers' compensation for hearing loss disability? Other costs include safety issues caused by workers' inability to hear warning signals and other communications over the sound of machinery, health problems related to workplace noise and loss of hearing, such as depression, stress, or cardiovascular disease, lost productivity because of city noise ordinance time restrictions, absenteeism, employee turnover and miscommunication, and loss of goodwill from surrounding communities who are fed up with uncontrolled noise pollution. Noise levels, like sound pressure levels, are measured on a decibel scale, or dBA, which corresponds to the ear's sensitivity to sound. Noise levels at your ears depend primarily on how loud the noise sources are, but they also depend on how close you are to the source and on the characteristics of the work area. Here's some perspective. At typical distances, a whisper is about 30 decibels. Normal conversation is about 60 decibels. And power tools are often between 90 and 110 decibels. Repeated exposure to sound pressure levels above 85 decibels, or from as little as one exposure above 140 decibels, can damage hair cells in the inner ear, causing permanent, irreversible hearing loss. At the worker's ear, this drill is measuring nearly 100 decibels. Hearing protection can be helpful and should be worn correctly to be effective in any hazardous noise situation. But when worn correctly, it could interfere with your need to hear important communications and signals, so it can't be your only line of defense. One of the best ways to protect yourselves, your employees, and your communities is to buy quieter tools and equipment. Let's take another look at how Buy Quiet can help. The Buy Quiet Power Tools database will help you find quieter tools that will get the job done just as well. The noise energy, or sound power level, is also rated in decibels. The higher the sound power level of a noise source, the higher the sound pressure levels will be in the work area. Did you know that buying a tool rated just 3 decibels lower than your current tool cuts the noise energy reaching your ears in half? In many cases, the initial purchase can even be less expensive. A little really does go a long way. And that's just our drill. Imagine if all tools were quieter. With the Buy Quiet Power Tools online database, you can compare specifications and sound power levels for a wide variety of brands and models, from drills and sanders to grinders and saws, and you can use that information to inform your buying decisions. Your participation in the Buy Quiet program lets your employees, customers, and the community at large know that you care about reducing noise and protecting hearing. And that can be a competitive advantage for your customers who want to minimize construction-related noise complaints in their neighborhood. When contractors improve safety by collectively prioritizing the purchase of quieter equipment, they can influence equipment manufacturers to make sound emission information readily available, and strive towards making even quieter tools. Thanks for doing your part in reducing hearing loss in the construction industry. If you'd like to begin your own initiative, click on NIOSH's Buy Quiet link for more information.
Noise reduction step 2. Make it quiet. When buying new, quieter equipment isn't an option, you may need to look at ways that you can reduce the level of noise that a particular piece of equipment generates. These types of engineering controls might include the adding of mufflers, enclosing the piece of equipment, or modifying the piece of equipment to reduce vibration or to dampen the noise that its moving parts make. An example of this type of modification can be reviewed in MIOSHA's guidance document for the control of noise for saw blades. This basic guide illustrates how an existing piece of equipment can be modified along with work practice controls to reduce noise exposure for a particular piece of equipment. It is important to consult with the equipment manufacturer prior to making any modifications to a particular tool or piece of equipment to verify that the modification will not interfere with the safe operation of the equipment. Noise reduction step 3. Keep it quiet. The third element of a noise control process involves an ongoing commitment to include noise controls into daily tasks. The process needs a support system to continue operating without daily conscious direction. Employees must understand the importance of maintaining and caring for the engineering controls. Ongoing standard practices for maintenance should include a common systems approach to controlling noise problems and communication protocols, integrating noise control practices into production and maintenance tasks, and increasing awareness for the noise control opportunities. Personal protective equipment, a primer on selecting and understanding noise reduction ratings. There are a wide variety of hearing protectors that are available on the market today. The picture here shows just a small sampling of devices that are available. It is important that in addition to selecting a device, that it is both comfortable for the user and provides an appropriate level of noise reduction. Employers must also recognize that the noise reduction features of a hearing protection device might make it difficult to hear other warnings that may be important for safety. PPE and noise reduction methods are just part of a larger safety and health management system that must be maintained and whose systems must work together and support each other. The EPA selected the noise reduction rating as the method to measure a particular hearing protector's ability to reduce the amount of noise exposure that a worker is subjected to. PPE noise reduction ratings. NRRs can range from 18 decibels up to about 33 decibels and provide an estimate on how well the plugs or muffs reduce noise. However, lab reports have determined that this number does not accurately portray the level of protection that an employee would receive when used in the field. One method that can be used to more accurately determine the effectiveness of a plug's noise attenuation is to take the NRR number and subtract 7 decibels. The remainder, in this case 26, is subtracted from the A-weighted, time-weighted average to obtain the estimated noise exposure under the hearing protector. Hearing protectors must attenuate or reduce employee noise exposures to at least the permissible exposure limit, 90 decibels, or the action limit, 85 decibels over an 8-hour day, for employees that have experienced a standard threshold shift. Many manufacturers recommend that the NRR number be reduced by 50% to better simulate actual workplace conditions. In this example, we're going to look at running a jackhammer for 8 hours. A jackhammer has an approximate decibel range of about 102 decibels. So in very loud environments, such as 100 decibels, it is recommended that both plugs and muffs are worn at the same time. Muffs worn in addition to plugs will provide only another 7 decibels worth of protection. In the example shown here, we're using a jackhammer for 8 hours with a noise level of 102 dBA. Our normal duration for this activity, without hearing protection, would be an hour and a half. In this example, we are using muffs as our hearing protection device, which have an NRR of 30. Using the methods described by OSHA for calculating exposures, we would reduce the NRR by 7, then divide the remainder by 2 and subtract that from the 102 decibels. This would give us an exposure of 91 decibels behind the muffs. This would still leave us overexposed after 8 hours, so we could either reduce the time the worker spends doing the activity to less than or equal to 6 hours, or we could also have him wear earplugs under the muffs. This would give him another 7 decibels of protection, reducing the exposure to 84, which is below the actual limit of 85 decibels for the standard. In summary, to reduce exposure to occupational noise, employers must first perform an assessment of their operations to determine where exposures could exceed 85 decibels over 8 hours. Evaluate engineering, work practice, and administrative controls to reduce those exposures. 3. Develop and implement a hearing conservation program. 4. Train employees on the hazards of noise and the protective measures implemented. And 5. Perform ongoing evaluations of the program to assure that it is effective. Additional resources that employers or employees can use to get additional training on hearing conservation are listed here. The organizations listed here also contain a variety of additional resources, training materials, and links to hearing protection device manufacturers to help you on your way to protect your ability to hear.